Hi class, today we're looking at Chapter 4, Lesson 2, Graphing Linear Functions. So the graph of a function is the set of ordered pairs consisting of an input and the corresponding output. These ordered pairs are the solution of the equation. A graph of a line may include solutions that do not appear in a table of values on the equation. So the y-intercept is the point where the graph crosses the y-axis. Let's write that down. So the y-intercept is the point where the graph crosses the y-axis. So just to be clear, if you are looking at a graph, so that's what this is here, you will think of this, right? So this is the x-axis, and this is the y-axis. So when it crosses right here, this is considered the y-intercept. So the y-intercept on this one is 5. So when you have an equation, slope-intercept form, that's what this is right here, this equation. Anytime it's set up with y equals this number after the plus sign, or it might be a minus, which means it's a negative number, is the y-intercept. Okay? This is the slope. The number before x is the slope. Let's do that in a different color. Okay, so the slope, right, we looked at slope yesterday, is -3/4. So rise over run. So it goes down 3. Here's where it crosses. Down 3/4. 1, 2, 3, 4. And there it is. So that shows us how the line is formed. And right now it's a negative slope. It's going down. So slope-intercept form equals y equals mx plus b. And in this equation, m equals the slope and b equals where it crosses the y-axis. Okay? If you know where it crosses the y-axis and you know the slope, you can define the line. So a linear function is a function with points that lie on a line. Let's go ahead and write that down. So linear function, a function with points on a line. So if it's not a linear line, if it's not a straight line, it cannot be defined by the slope-intercept form. But as long as it's a straight line, this will work. So you can write a linear function in the form of y equals mx plus b. Then you can use the slope and y-intercept to graph the function. So let's take a look at a couple and see how we do. So find the slope and y-intercept. So if we look at these, what did we say? We're going to say that the slope I'm going to define as green and the y-intercept as y. So the slope, it's as long as y is first, y equals, as long as it's in that form, it can be the form, the slope-intercept form. So therefore the slope is 2 because it's right before the x and that's where we know the slope lies. And the y-intercept is 4. So you would just write this as slope equals 2. So that means rise, and anytime it's just a solid number of 2, any number can be over 1. So 2 over 1. So it goes up 2 over 1. That's the slope. And the y-intercept equals 4. So that means that if you were graphing this, it doesn't ask us to do it there, that it crosses 1, 2, 3, 4 right here at the 2. I'm sorry, at the 4, and then the slope is over 2, up 1, or back 2, down 1. So that's going to be where you would graph it. Okay, but it's super easy to find the slope and y-intercept as long as it is in this equation form. So the next one, right, so our slope is going to be -5 over 6. And the y-intercept, so this is a little tricky, is going to be -7. So whatever this sign is in the middle needs to go with it. So that tells you if it's positive or negative. So this is going to be a -7. So our slope, -5 over 6. And our y, I'm going to abbreviate that there, intercept is going to be -7. Okay, try number C on your own. Come back to me when you're done. So this one was a little tricky. There was not a number before the x. Well, whenever you just have an x, it's like having a 1 in front of it. So therefore the slope is 1. So that means over 1, up 1, over 1, up 1. So the y-intercept is -3. So if we were to, let's just for fun graph this. Okay, so it crosses the y-intercept at -3. And then the slope is rise over run, up 1, over 1, up 1, over 1, up 1, over 1. And that would be our graph. Okay, so there's more than one way to do this. So these students were told graph the function y equals 3 over 5x plus 1. So we know, right, this should be the slope, this should be the y-intercept. So this student, Kevin, says, first I'll make a table, then I will graph the points. So what he did is he plugged in 0 for x, and he realized when that happens, y equals 1. And then he plugged 1 in for x. And when he solved that equation, y equals 1.6. And so on. So this is a great way to find out all of those points, right? So that's one way to do it, absolutely. But then Michelle here, she says, I can just use the slope-intercept form to graph the equation. The y-intercept is 1, and the slope is 3/5. So she took it, and she put the y-intercept, 1, and then she did the slope, 3/5, rise over run. Up 3, rise over 5. And there's that next point. And then she did it again so that she could really tell where the line went. Either way is correct. You can choose which way works best for you. So let's try it. Go ahead and try to graph the function y equals -2 over 3x minus 2. Come back to me when you're done. Okay, so I went ahead and did a graph here. So the y-intercept is -2, and then the slope is -2 over 3. Or it could be, remember how we talked about with slope, it could be 2 over -3, and I'll show you why that kind of matters here. So here we are. I'm going to do it Michelle's way first. So to do that, I'm going to go down 2, rise, over, run, over 3. 1, 2, 3. And then see, I'm going to turn it around and do the negative as the 3. So that means I'm going to go up 2, and then I'm going to go negative 3. 1, 2, 3. So here's my line. Okay. So that's Michelle's way to do it. I personally like doing it that way better, but sometimes it is more difficult. So let's check out Kevin's way. So if we did, erase these here. Okay, so if we made a chart and we're going to do X and Y, X equals 0. So if we plug 0 in here, then Y is going to equal negative 2. If X equals, and I'm going to just plug in 3 because I know that 3 will cross that out. So if X equaled 3, these get crossed out. Negative 2 minus 2. Negative 2 minus 2 is going to equal negative 4. Okay. So then if we plug in, let's do, I mean, you could plug in other numbers. You could plug in like 4. It's just you're going to end up with a fraction, and it's hard to graph fractions on it, but let's do it just for fun. So let's do 4. So we go negative 2 over 3 times 4 minus 2. So this is going to be negative 8 over 3 minus 2. So to subtract 2, we want them to have the same denominator. So I'm going to want them both to have 3 at the bottom. So that means if I'm going to have 3 at the bottom, I multiply this by 3. I have to do it to the top. So this turns into 6 over 3. So then we have negative 2 minus 6. So that's going to be a negative 14 over 3. So if we divide that out, 3 goes into 14 4 times, and we have 2/3 left over. So that would be a negative 4 2/3. See, so that's going to be kind of hard to graph. So I would do a 6 because 6 could be crossed out. So 6, negative 2, you can see this, Kevin's way is a little bit more time consuming. That turns into a 2. Negative 2 times 2 is negative 4, minus 2 is negative 6. Okay, so then we plug these numbers in. 0, negative 2, so X is 0, Y is negative 2, that's where our y-intercept is. And then we go 3, negative 4. And then I'm going to skip that to do 6. 4, 5, 6. Down to 6. And if you see, you can get the feel for where it goes, and it would be covering the same line. So either one is correct, whatever way you prefer. So below the graph is the graph y equals 2x. So now what happens? We don't, if we're using, so notice that the slope of the line is 2 over 1 or 2. Since the graph passes through the origin, the y-intercept is 0. So that's why we could put plus 0 at the end and it not change it, and that's where the y-intercept is. So if it does not have anything at the end, then the y-intercept is 0. So some key concepts to keep in mind. The slope-intercept form of a line that intersects the y-axis A at B, sorry, this should be a T. At B is y equals mx plus b. The slope-intercept form of a line that intersects the y-axis at the origin, so the origin means 0, 0, is y equals mx. Okay? Now, if we are looking at graphing functions of the form y equals mx, so if we had the function y equals negative 4/5 x, where it represents the temperature and the x represents time in minutes, they want us to graph it. So the first thing we do is start at the y-intercept, which is 0, 0. The slope is negative 4/5. So we go down 4/5, down 4/5, and we are able to graph it. So now let's graph the function y equals 1/5x. Try that on your own. Come back when you're done. Okay, your line should look similar to this. I started with the y-intercept at 0, 0, and then I went rise over run, up 1, rise over run, over 5. And then because my graph was like this, you can always make these both negative. Down 1, back 5. And then that is the line I came up with. So your homework for today is page 126, 3 through 19 odd. Happy homeworking!